All right, so when you're working in Java, building any kind of big, complex software, it's a lot like trying to build a skyscraper. You can't just wing it, right? You absolutely need a blueprint. But which kind? Today, we're going to dig into the two master blueprints Java gives us for taming that complexity: abstract classes and interfaces. Let's figure out which one is the right tool for your next big project. I mean, really think about it. If you were building a massive skyscraper, you wouldn't design every single floor totally from scratch, would you? Of course not. You'd start with a master plan, a blueprint that lays out the essential structure for every floor. That's what gives you consistency and saves you a ton of work. Well, guess what? In programming, we need that exact same idea. And that whole idea of a master plan, it really boils down to one of the most important principles in all of programming: abstraction. You can think of it as, well, the art of hiding all the messy, complicated details so you can focus on what's important. So, what is abstraction really? Well, it's all about focusing on the what an object does and not getting bogged down in the how it does it. It's kind of like driving a car, right? You just need to know how to use the steering wheel and pedals. You don't need to be a mechanic who understands every single detail of the engine just to get from point A to point B. Abstraction is what lets us use complex code without getting lost in the weeds. And that brings us right back to our main event. In Java, we've got two primary tools for creating these kinds of blueprints. We have the flexible abstract class and the super strict interface. All right, let's kick things off with our first tool, the abstract class. The best way to think about this one is as a kind of partial blueprint. It gives you a really solid starting point, but it still leaves some of the final specific details up to you. So an abstract class is this special kind of class that you can't actually instantiate. You can't create an object from it directly. Its whole reason for being is to act as a parent, a template that other more specific classes can inherit from and build on top of. Okay, now what's really cool here is how it can mix different kinds of methods. See that abstract method? It doesn't have a body. No curly braces, no code. It's basically just a rule. It says, hey, any class that inherits from me must provide its own version of this method. But then, right below it, you've got a normal, concrete method that's fully implemented. This is awesome because it provides common, shared behavior right out of the box. So when would you actually reach for an abstract class? Well, this table lays it out pretty clearly. You use one when you want to enforce some rules, making sure every child class has certain methods, while also giving them some shared, ready-to-use code to start with. It's really the perfect blend of here are the rules and here's some help to get you started. Okay, let's switch gears to our second tool. If an abstract class is that flexible blueprint, then an interface, well, an interface is a strict, unbreakable contract. You see, an interface takes abstraction to a whole new level. It is purely a collection of method signatures, just the names and parameters. It makes a very simple, very powerful promise. Any class that says it's going to implement this interface has to provide its own code for every single method on the list. No exceptions. Just look at the code here. See how simple it is? There's no implementation, no logic inside curly braces, nothing. It's literally just a list of capabilities. The interface could not care less how you write the code for method 1 or method 2. Its only concern is that you do write it. And the payoffs for this are huge. First, you get 100% abstraction. This helps you build what we call loosely coupled systems, which is just a fancy way of saying changes in one part of your code are less likely to break something completely unrelated. And the big one, the most important reason, interfaces solve a fundamental problem in Java. They allow for a form of multiple inheritance. Now, hang on to that thought, because we're going to come back to it. It's a total game changer. I absolutely love this way of putting it because it just nails the concept. An interface is a promise. It's a contract. When your class says it implements an interface, it's literally signing on the dotted line, promising to deliver on all of that functionality. Okay, so we've met both of our blueprints. Now it's time for the head-to-head comparison. Let's put them side by side and really break down the differences. All right, this is the showdown. This is where it all comes together. Let's get into the nitty-gritty and settle this once and for all. Okay, let's walk through this table. First up, methods. We know abstract classes can have that mix of abstract methods and normal ones with code. Now, interfaces used to be only abstract methods. That little note about pre-Java 8 is there because these days interfaces can have default methods with code, which kind of blurs the lines, but the core idea is still there.
Next, variables. In an abstract class, they can be anything. But in an interface, they're automatically constants: public, static, and final. You can't change them. The keywords are easy. You extends a class, you implements an interface. And now for the knockout punch, multiple inheritance. A class can only extend one abstract class. That's it. But it can implement as many interfaces as you want. This is the big one. Yeah, that last point about multiple inheritance is so important. It really needs its own moment. Because interfaces are Java's super elegant solution to a really tricky problem in programming.
So here's the deal. In Java, a class cannot inherit from two different parent classes, period. And there's a really good reason for it. It's to avoid something called the diamond problem. Just imagine you have two parent classes, and both of them have a method with the exact same name, like do work. If a child class inherited from both, which version of do work should it use? It's totally ambiguous. So to avoid that whole mess, Java just says, nope, you can't do that with classes.
But this is where interfaces perform their magic trick. Look at this example. Class C can implement both interface A and interface B at the same time. And because interfaces don't provide any code, they only provide the contract, there's no conflict to worry about. The class itself is the one that promises to write the actual code for the methods from both interfaces. It completely solves the problem. It's just brilliant.
And this really brings us to the final, most important takeaway. If you're going to remember one thing from all of this, let it be this. Interfaces define what to do. They're the list of capabilities. The classes that implement them decide how to do it. They provide the actual concrete logic. So the next time you're starting a new project and you're at the design stage, just ask yourself this. Do I need a common base, something that provides some shared code for a family of related classes? If so, an abstract class is probably your answer. But if what you really need is to define a set of capabilities, a contract that lots of different unrelated classes can agree to, then an interface is absolutely the way to go. You have the tools. The choice is yours. Which blueprint are you going to use for your next big idea?